Very good evening. This is Dr. N.C.Linear Professor in Electronics and Communication Engineering Department, St. Peter's Engineering College, Hyderabad. Today, I would like to continue the session of the tutorials, which is the previous tutorial. We did a lot of exercises on signal characteristics. Like you say that the causal, non-causal, periodic, aperiodic, and a lot of the shifting properties, scaling property, all. We did all these things. So now we are going to talk about the systems. And already you know that what is the classification of systems. Systems may be classified in a different categories, like a continuous and the discrete time systems generally. And a system generally, any process that exhibits cause and effect relation can be called as a system generally, right? So now we used to take a system will have an input signal and an output signal, and it have some process in between. That process which is done by the item is called a system, you say that. So here a system is either and the interconnection of hardware devices or the software by algorithms like that. Okay, just to say that in this figure, just to observe that a system is denoted by the transfer function. You say that generally used to take here, this is generally indicated by h, this is the transfer function h of s, generally used to take in a Laplace transformation and all. But you say that this is indicated like this, h, the transfer function. The transfer function is the ratio of the output to the input. That means the ratio of response to the excitation. So, or otherwise the ratio of the output to the input. This is called a system generally, right? So, used to take generally a system can be classified in a many ways like that. That is, you say that the continuous and the discrete time systems, as well as the lumped parameter and the distributed parameter systems, static and dynamic systems, and moreover causal and non-causal systems, as well as linear, non-linear systems, and another is the time invariant and the time variant systems, stable and unstable systems. All types of systems we discussed in the previous lectures. Now we are going to do somewhat the tutorials, which is the high level, like you say that the competitive examinations like a GATE and IES or any government sector, the public sector competitive examinations, so the students has to attend like this the simple and the logical problems, which will give the excellent enhancement in their skills in mathematical analysis, right? So now we used to take the continuous time system generally. A continuous time system is one which operates on a continuous time signal and produces a continuous time signal, continuous time output signal, you say that, right? So that is called the continuous time system. So here in this figure, just to observe that this is the input excitation, the output, this is the response, you say that. And generally used to take for the continuous time systems, you say that x of t here, and here you say that y of t, and here it is called the h of t, you say that generally, right? So this is the continuous system. If you will take another the discrete time system, discrete time is x of n, y of n, and h of n, like this. Right, this is about the system general description. Now you will take the continuous time system, which is indicated by x of t, which is the CTS means continuous time system, which is the in sense of the time variations like x of t and y of t are input and output respectively. And here you say that the h of t, which is called the transfer function. So here you used to take the tau, you say here. Now y of t is equal to tau into of x of t, like this. So therefore here example, just to observe that the y of t is equivalent to the ln of x of t, you say like this. So, here which is y of t is equal to x square of t. This is only for example, right. So, now the designing of the system is called the synthesis and getting the output is called the analysis, right. The both things we need to know in engineering capability, like analysis and synthesis, both will be required, right. So, in this generally used to take the how the differential equation or difference equation, already know that the differential and the difference equations, like you say first order difference equation, first order differential equation, second order differential equation, like that, and the transfer function model, which is either the h of s or h of n, like this. Just now we will say the transfer function is the output to the input ratio. So, again we will comes to the impulse response function, which is h of t or h of n, like this. This is the impulse response function, the state space analysis, like. So, this is actually the way of approaching how the system responses and all, right. So, now the it may be considered the linear, stable and invertible. This is considering an amplifier. This is for example, you say that what are the amplifiers, already know that the small signal and large signal amplifiers. Generally used to take a small signal amplifier C, CB, CC amplifiers. Now used to take the invertible. Invertible means, for example, the C amplifier is there. What is actually the C amplifier? C amplifier, you say that generally that is just like the 180 degrees phase shift. The output is the inverse of the input, that is invertible. The stable operations will come into the picture here. So, it is basically transistor or the amplifier is depends on the basic three characteristics, like the beta factor and the faithful amplification conditions, like you say the VB is always a forward bias condition, VBC is a reverse bias condition, like this. The minimum VB need to produce, that is 0.7 volts, like this, and you say that the proper zero signal collector current. These all are the transistor parameters, what the sustainability of the transistor in a faithful amplification conditions. So, the linear, stable and invertible, which is considering in the amplifiers. Now, you used to take again the another the time invariant, static and causal, which is generally used to take the time invariant. Time invariant means there is no variation with respect to the time. The output should not be varied with respect to the time, that is the time invariant. If it is varied with respect to the time, there is a time variant, already you know that. So, static, already know that. Causal means only t is less than 0, it have some the values, the past values, then we consider as a causal. If it is a future, it is a non-causal conditions. And the linear, yeah, that is a briefly given. Now, we are going to talk about this. After that, we will go to the some tutorial problems. So, now what is a linear non-linear systems? It provides superposition, additive and homogeneity properties. That means superposition principle should satisfies, then the system call it as a linear actually. So, here you say that the additive, for example, you say already I told all these things in the previous sections, but I will briefing all these things for the basics for the point of student. So, x1 of t, which is the y1 of t, and x2 of t, which is y1 of y2 of t, you say that. So, these two inputs will add, then output will also add. This is additive property which will satisfies, and the scaling homogeneity. For example, you say that the alpha into x of t, the same factor should be multiplied in output, that is alpha y of t. The alpha need not be real, it can be imaginary also, no problem, but the same thing should be replica with the same factors, that is a homogeneity property. So, you say that y of t is equal to x of t into x of t minus 3, you say that. So, for example, x1 of t tends to the y1 of t, and which is y1 of t is x1 of t into x1 of t minus 3. And similarly, you say that the x2 of t tends to the y2 of t, and therefore, x2 of t and into x2 of t minus 3, right. It should be satisfied, then that is the linear. If it is not satisfied, there is a non-linear. That is the condition actually. So, here just you observe that y of t is equal to x1 of t plus x2 of t, like this. both will be added together and you will get the x1 of t plus x2 of t, x1 of t minus 3 plus x2 of t minus 3 like this, therefore which is y1 of t plus y2 of t. But both will be, the combination is not equal to the y of t, so this is a non-linear. Okay. For example, another, just to see that y of t is equivalent to the x of t cos phi t. So therefore x1 of t is equivalent to the y1 of t, generally you say that. What is x1 of t? x1 of t into cos phi t. For example, you say that x2 of t tends, therefore y2 of t is equal to x2 of t into cos phi t. The both will be adding x1 of t plus x2 of t, therefore which gives the y of t, and you may add cos phi t is common, so therefore it should be satisfied, then the system is a linear. Okay. So y of t is equal to y1 of t plus y2 of t. Just to observe that here, just to see that. So here you may take, this is the cos phi t, because that is multiplied to that, the both will be satisfied with the y1 of t and y2 of t, then the sum of the y1 of t and y2 of t equal to y of t. So therefore this system is a linear. So this is the way we have to identify whether the system is a linear or non-linear, which is depends on the additive and homogeneity conditions. So now unknown signal product make the system non-linear. For example, you say the y of t is equal to x of tau into d tau, which is in between the minus infinite to the t. So this x of tau, which is a linear, just you see the same. For example, y of t is equivalent to the sample into x of t, you say that the system operation is a sampling, right? So therefore the amplitude is not changing, so it is also a linear. So like this is the sampling is a linear operation, but the time dependent Ts, so the time variant will be there. So for example, you say the another the y of t is equal to sine of x of t, because it should be varied with respect to the sinusoidal wave, so this is a non-linear. Example, y1 of t is equal to sine of x1 of t, y2 of t equals sine of x2 of t, like that. The both y of t is equal to sine of x1 of t plus sine of x2 of t, the both will be applied here, sine of x1 of t plus sine of x2 of t, and the both will be in a different manner. So therefore it's not equivalent to the y of t, so therefore it is a trigonometric functions, so the output is a trigonometric functions, then the system is always a non-linear condition. Okay. So now you may take the y of t is equal to m of t mod. All positive and negative values will be there, so therefore the system is a non-linear generally, the output due to the minus 5x of t. So whether it is in a mod, either plus or minus will come into the picture. So you may take both the minus 5x of t, which is not equal to plus 5x of t. Therefore y of t is not satisfied with this, though this system is a non-linear. The modulus of input makes the system non-linear because it negative values and positive becomes a positive values, like that already I told. So the similarly y of t is equal to 3x of t plus 3, which is also non-linear. For example, you say that output due to the output due to the proportion of the y of t, so therefore the scaling alpha should be multiplied to it, then you will get like this. So due to the alpha x of t, which is the 3 alpha x of t plus 5, like this. So which is non-linear, which is not satisfied. The addition of a constant makes the system non-linear. This system is also called as a incremental linear, since the output is increasing because of the constant terms, like that. Okay. So this is the about the non-linear system and the linear system difference. And for example, you say the exponential function y of n is equal to 2x of n, 2 power x of n. You will take y1 of n is equal to 2 power x1 of n. Similarly, y2 of n is equal to 2 power x2 of n, like this. If you will take output due to the x1 of n and x2 of n, the combinations, then you will take both the 2 power x1 of n and 2 power x2 of n. So therefore 2 power x1 of n plus 2 power x2 of n. So therefore which is not equal to the y of n whatever we stated as the superposition or the additive property. So, therefore, it is a non-linear condition. So, exponential terms makes the system is a non-linear for this problem. And similarly, used to take the y of n is equal to signum function of x of n. You know already signum function, so which the amplitudes will be maximum at the level of you say that the 0 either plus or negative side like this. So, therefore, this is signum function at the 0 level, the both will be like that, just like this. So, this is the signum functions, you say that this is the signum function like, okay. So, at the 0 level this is like this, and you will take from this side it is minus 1, this side it is minus 1, this side it is a plus 1. So, this is actually the signum function like this, right. So, according to that the system is non-linear, because one is x of n is greater than 0, another one is x of n is less than 0. For the signal we are always maintaining a constant amplitude of a plus or minus 1, so it is a non-linear. When output signal is the input dependent on, then it is always a non-linear property. So, now the y of n is equal to x conjugate of n. So, output due to the 2 plus j3, this is a conjugation. What is the conjugate of 2 plus j3? 2 minus j3. So, therefore, 2 plus j3, which is the 2 plus j3 of x of n conjugate, which is equal to 2 minus j3 x of n. So, therefore, which is the alpha x of n is equal to the 2 plus j3 into x of n. So, which is also a non-linear system, which is not satisfies the superposition property, and the y of n is a real, you say that real x of n. So, therefore, the output due to the 2 plus j3 is equivalent to the only real term will come out. So, therefore, this system is also non-linear. So, the real and the complex part and the conjugate are non-linear. So, how is it? Y of n is equal to median of x of n, you say that. So, therefore, the output of 1, which is the 1, 2, 3, 4, 5 like this, the median is 3. And similarly, you say the output to 1, 1, 2 and 2. So, therefore, the output which is the median, which is used to take here how many is there, the 2, 1, 3, 2, 5, 5 to 7, generally used to take only 1 like that. So, therefore, the outputs is gets equivalent to the 4. So, you used to take generally all will be right like this, and you will take the output 1 plus output 2, both will be get 2 plus 2, which is equal to 2 plus 2 by 2 equal to 2, that is the median. So, therefore, here which is not synchronized or coincides, so therefore, the system said to be linear, sorry, non-linear. So, again you say that the another one, quantization is non-linear and the sampling is a linear operation, right. So, the phase plane analysis, you say that the non-linear, the two system connected in series. Now, we are going to take what is system? We know that it consists of output and input like this. When the input is giving to the system, and it will give the outputs with somewhat variation or the constant, whatever it may be. So, it is depends on the factor which is inbuilt in a system itself, that is called the process. So, now the types of systems, the systems, two systems will be connected in series or a parallel or any variations. So, just will say the two systems are connected in series. You say that system 1 and system 2 like this. This is a non-linear exponential function e power x of t, and here it is the natural logarithm. You say that ln x of t, you say that this is systems both will be connected like this, and you will get the y of t is equivalent to the x of t. So, you used to take this is the linear consideration. If you will take another, and the one is the x of t, S1 system will connecting. Here you say that S1 system is connecting like this, the S2 system is like this. One is the root, other one is the exponential. Both will be different. But here both will be the, one is the reciprocal of the another. So therefore, here used to take like this, a little bit same. But here it is the x of t which is gives to the root, and another it should goes to the exponential, which will gives the output, which is clearly non-linear, because not satisfied the principle. So it is the system is a non-linear. When both S1 and S2 are opposite to each other, then it becomes a linear. This satisfies the first system. This is both will be opposite to each other, right? So therefore, the system said to be linear. The two systems are connected in parallel now. So for the above two connections, for this system it is a linear, this is a non-linear. Where it should be possible linearity is the one another, both will be the opposite to each other, then the system will be a linear, right? If we will coming to the two systems are connected in parallel, what is happen? Just we will take like this is the natural logarithm. So here both you say that x of t, which will be connecting like this, 3x of t plus 3x of t minus 3 here. Then both will be summing and we will get the output like this. Just you will observe that 3x of t plus 3 here, 3x of t minus 3 here, both will be combined, 3 cancel, only we will get this 6x of t. So therefore, whatever the signal strength will be there, that will be coming out with somewhat factor, because these two are the one is the 3x of t plus 3, other one is the 3x of t minus 3, both will be cancelled and we will get like this. So this is a linear. If you will take one is a non-linear, both will be a non-linear, these two are. This is non-linear, this is non-linear, and we will get only linear. If the another one is linear and another is non-linear, and we will get the non-linear. So here just to observe that the x of t, which is giving the linear x of t, non-linear is x of t plus 3. So both will be combined together and we will get the y of t is equal to 2x of t plus 3. This is the non-linear. Try to understand. If the two systems are a non-linear, which will be connected in parallel, and we will get the output is linear. If the one system is another system is non-linear and both will be connected in parallel, then the system output will be a non-linear. And similarly used to take the time invariant by shift invariant. If you will take a system is a time invariant if input and output characteristics do not change with the time. That is the time invariant. Already I say that, I told already this is. What we say that if you are giving a input with the some timing and all, it should not be changed with respect to the time at the output, that is called the time invariant. Okay. So shift invariant also same, just to observe. If you will take x of t tends to the y of t, similarly x of t minus t e naught, which tends to the y of t minus t, that is called the delay, second one. This is shifting, time shifting. Just will take a time invariant. If you will take y of t at a t equal to the t naught and y of t which is t equal to the t minus t naught, right? This is the time invariant. At the t naught time also, delay time also, there is no variation. Now you will take exactly, this is the input, you say that, and you will get the output like this. X of t you will give and we will get the output y of t like that. Then how you are going to write this? X of t minus 2 this is, which will start at the right shifted side up to 2, it should shift and it should go up to the 4. X of t minus 2, this is the delay. Y of t minus 2, this is also delayed by 2. Previously it was start at the 1 point, but here it is start at the 3rd point. This is called the delay, shifting or whatever. Okay. So now just will take a good example. Y of t is equal to t into x of t. The output due to the delay input, you say that y1 of t is equal to the t into x of t minus t naught, where you say the delay output by the t naught, which is the t, instead of t you say that the t minus t naught. y of t minus t naught equal to t minus t naught into of x of t minus t naught, which is not equal to the y1 of t. So therefore, you say that the time variant, so x of t is here, multiply by t, which is the t u of t, you say that, and somewhat delay will be there. So therefore, delay is involved. Now again you may rewrite that the equation which we have, the t minus of some value u of t minus some value, okay, or 1, you say that, no problem. So delay by 1 unit here, just to observe that this is the unit step function. If you will take this is the delayed by 1 unit, then it is what is the shifted right side, u of t minus 1, and you will take the multiply by t here. So therefore, t into u of t minus 1, this is like this. About the time invariant and time shifting, like this, the y of t is equal to the e power minus x of t. Time invariant, y of t is equal to e power minus x of t minus t naught, you say that, and similarly y of t minus t naught equal to e power minus x of t minus t naught. Similarly, used to take, this is the time invariant, y of t is equal to x square of t, for example, y of t is equal to x square of t minus t naught, y of t minus t naught equal to x square of t minus t naught. So the time invariant. For example, you say the y of t is equal to x of 2t. So you will take input, you say that the y of t is equal to x of 2t minus t naught, you say that y of t minus t naught equal to x of 2 into t minus t naught, then x of 2t minus 2t naught. So which is varying with respect to the input, so therefore it is a time invariant. Output will varies with respect to the time, 2t minus 2t naught, but there 2t minus t naught, so which is not equal. So this function is a time variant. Similarly, used to take the y of t is equal to x of minus t. So you say that the input, how you will get the y of t is equal to x of minus t naught, you say that y of t minus t naught is equal to x of minus of t minus t naught. So therefore, x of minus t plus t naught, minus of minus is plus. So this is the time variant. This is the signals indicated for the time invariant and time variant. In general, you used to take x of alpha t, which is TV. You say that alpha is not equal to 1, right? So now you used to take y of t, which is equal to differentiating with respect to the t of x of t. Now you used to take the y of t minus t naught equal to d by dt of x of t minus t naught by t minus t naught with differentiating. So you take dx of t minus t naught by dt, you say that. So here d by dt of t naught equal to 0, already you know that, the constant term here. So therefore it is the time invariant. And similarly used to take the another example where y of t, the x of t, at the x of t is greater than 0 and it is comes to 0 when x of t is less than 0. So here the amplitude dependent, which is a non-linear, and the independent of time, which is the time invariant, and you say that the y of t is equal to the x of t, where t is greater than 0 and it is 0, t is less than 0. The amplitude independent, which is the linear, time dependent TV, this is. And you say that the discrete time signal, just you say y of n is equal to g of n into x of n, where y of n is the input, g of n, x of n minus n naught. So again output g of n minus n naught into x of n minus naught. So which is the time varying, you say that. Here you say TV is called the time varying. Please try to understand that. Okay, just you may go this y of x is equal to 3 of x of n. So discrete signal, you say that. Input, you say, how you say that 3x of n minus n naught, and you say that output also 3 into x of n minus n naught, which is the time invariant signal. And again dy of t by dt plus t into y of t, which is equal to x square of t. this is the t into y of t, which is the time variant signal. So therefore it should not be matched, so the output is a non-linear. So the here you say that first degree of differentiation, the coefficient must be constant or invariant. So here the just you have to observe here the x is invariant, right. So therefore now used to take generally y is a differentially with respect to dy by dx. So now you say here generally d square y by dt plus 4yt, which is equal to 2x of t. So now again this is the linear, is a time invariant b bit. So here the linear time invariant system, that's equivalent to the second order function actually, dou square y by dou x square, dou t square, like dou square y of t by dou t. So because of a coefficient of the fixed time invariant in any differential equation, if one the coefficient are fixed only with linear elements, that is the linear time invariant system. So therefore input and output depending on the time. Okay, so that is a variation. You say that time scaling also varying, and the modulator signal multiplied by the sine or cos, which is also varying. So therefore the almost all will be varied with respect to the time scaling, with respect to the time, with respect to the amplitude also, or magnitude, whatever it may be, in the multiplying function also. Now used to take generally, this is the signal given. So x1 of t, which is the first figure, this is the second figure. You say that how you are going to write this generally. This is the first and second, which is positive edge is there. So here it is the second one is the negative, -1 to +1, but here 0 to 1 only, 0 to 2 here, like this. It may be changed with respect to that. So here x2 of t equivalent to the x1 of t minus x1 of t minus 2, right. So the LTI given like this, and the x2 of t, which is equal to y1 of t minus y1 of t minus 2. So therefore you may take like this. That is the, just to observe, x3 of t, which is equal to x1 of t plus 1 plus x1 of t, like this, right. x1 of t plus 1 plus x1 of t, yeah, this is y3 of t equal to y1 of t plus 1 plus y1 of t. So therefore like this, and you will take, this is the diagrams which they are given. The y1 of t plus 1 is like this, y1 of t is like this, both will be combined and you will get like this y3 of t. This is the final signal. And now x1 of x of t tends to the y of t, which is a linear time invariant system. Initial conditions y of 0 equal to 0. For a LTI system, the same relation is valid for input and outputs. And now the causal and non-causal systems. A system is a causal if the present output depends only on the present input and past values, so of the input, but not the future values. That is, the causal systems are non-anticipative. That means a system is said to be causal when it is possible only the present input depends on present output depends on present input and the past values of the input, but it is not depending on the future values of the input. So that is called the causal system, and it is non-anticipative, which is just like you say that the y of t is equal to 3t plus 1 of x of t, like this. This is a causal automatically. So similarly used to take the y of t is equal to x of t cos omega naught t. This is also causal. So you may take the another, the y of t, sine of x of t. Yeah, this is also causal. And if we will take the y of t is equivalent to the x into of sine of t, you say that sine t equal to 0, then the t is equivalent to the either plus or minus m pi, because the pi, n pi values of the sine is 0 absolutely. Sine 180 0, sine 360 0, like that. So therefore, the sine of t value must be in terms of the plus or minus m pi, where m is an integer, either 0, 1, 2, 3 like this, then that is sine t equal to 0, and the y of t is equal to x of 0 like this. Then you will take the, if you will take instead of t is equivalent to the pi or minus pi, you say that only, then it comes to the 0. So therefore, y of minus pi is equal to x of 0, and it is expected the feature value of the input. So therefore, the system is a non-causal system. Okay. So this is the good example for the non-causal systems. And y of t is in between the minus infinite to the 2t, so 2 tau into d tau like this, or x of tau into d tau like this. Again you will rewrite this equation. Y of t is equivalent to the minus infinity to, or y of 1 is equal to minus infinity to 2, where t equal to 1, you say that x of tau into dt. So this is the so this system is also non-causal system, because the value will be feature indicates y of t is equal to minus infinite to plus t, which is x of tau into d tau. So therefore, again y of 1 is equal to minus infinite to 1 x of tau into d tau, which is a causal, because the value is what is the past and present only. There is a causal. Now we will take the y of n is equal to 2x of n plus 3u of n plus 1, not affecting any causality, because the unit step function is there, 3u of n plus 1. So, but it is the x of n only causal signal. So, similarly y of n is equal to sigma of k equal to n naught to n x of k, where n naught is finite, you say that. If you will come into the case 1, which is n naught is greater than n, you say that the non-causal, 2 is greater than also 1, you say like that. So therefore, y of 1 is equal to the sigma of k equal to 2 to 1, you say the x of k, x of 1 plus x of 2 like this. So therefore, it is also depends on the feature value. So therefore, it is a non-causal system. And similarly, used to take the case 2, you say that the n naught is less than or equal to n. So therefore, and the k equal to 1 to 2, x of k, you say the x of 1 plus x of 2, where which is equal to y of 2. So therefore, it is a conditionally it is a causal, because the past and present values is present here. So for n naught equal to 0, then y of n is equal to x of k, you say that. So y of minus 1 equal to x sigma of k equal to 0 to minus 1, x of k, x of minus 1 plus x of 0 like this. So the system is a non-causal. And similarly, used to take the y of n is equal to sigma k equal minus infinite to plus n x of k, you say that it is accumulated. So therefore, which is depends on the past and present value. So therefore, this system is said to be a causal system, because just to observe that here x of minus 2, x of minus 2, x of minus 1, x of 0, x of 1, all systems are less than the present 1. So therefore, which is absolutely the past values and present value. So therefore, the system is said to be causal. If you will coming to this, the moving average system, you say that y of n is equal to 1 by 2m plus 1 sigma k equal to minus m to the plus m. So you take x of n minus k, the moving system, where m is equal to 1, the y of n is equal to 1 by 3 of sigma k equal to minus 1 to plus 1, x of n minus k like this. So again you used to take apply that the minus 1 to the plus 1 range, then you will take the n is equivalent to the k is equivalent to the minus 1 ones, again 0, again 1, then you will take like this 1 by 3 of x of n plus 1 plus x of n minus 1 plus x of n. So this condition it depends on present, past and future. So therefore this system is said to be non-causal system. So non-causal system cannot be designed when the independent variable is the time. You say that the t or n, whatever it may be. So now the y dot of t plus 4 plus 2 of t is equal to x of t plus 2. Where you say that t plus 4 is nothing but a tau, you say that y dot of tau, which is equal plus 2 of tau minus, because you say the t is equal to tau minus 4, no? So instead of t you say that tau minus 4 is equal to x of tau minus 2. So this system must be a causal, and here the present time is t plus 4. So therefore all timings are less than that. Therefore the system must be a causal. And the static by memoryless or a dynamic with the memory, whatever it may be. So here just to static to dynamic, static is nothing but a memoryless and the dynamic is nothing but a memory with. Static system is that in which the output at a particular instant, it depends only on the input at that instant only. That means there is no need of any past values or anything. So therefore this is static system, the present input, present output depends on the present input only. That is particularly the present instant. So therefore this is a static system, which we are going to take the y of t is equal to e power minus of t plus 3. So this is x of t and y of t, which relates like that, which is the present input only. So therefore that system is called the static system. And the second example, you say the y of t equal to 2x of t plus 3, which is also same. And you will take the y of n is equal to the g of n plus 3 into x of n, which is also static. Just will take, this is the y of n is equal to x of 3n. That means this is the multiple. So therefore it is a futuristic value is required, the memory. So dynamic, this is y of t, which is equivalent to the d by dt of x of t, you say that. So the differential term is because of the system is energy storing elements. So system is always a dynamic. All static systems are causal systems, right? So now you used to take generally this is x of t and y of t like this. How the variation is there in this? Before applying an input should not start. That is a causal, right? If the input is starting at 0 and the output is also starting at 0, then causal system. If we will take another y of t equal to 2 into of minus infinite to plus t, which is x of tau into d tau. So here which will be starts the causal and dynamic system, this is okay. So now we used to take the consider the functional block system, feedback system. You say that the shown in figure, and I assume that y of n is equal to 0 and is less than 0, then this is the signal x of n input and y of n output, which we have summing or error amplifier will be there, summing circuit is there, and which is the unit delay is there in this. So you used to find the y of n when the input is x of n is equal to del of n, unit the del of n, this impulse input impulse function is there, for example, then what is happened, and the unit impulse function is there, what is happened. Just from that circuit you say, and the error E of n, which is indicating like this, this is the E of n, you say that E of n is the feedback input and the some part of the output is fed back to the input. The both will be mixing at this point, error amplifier, and which will gives the output, that is called the error signal, that is indicated by the E of n. So therefore here the two inputs are taken to the account. One time input is the del of n, another time is the U of n. So from this just to observe that En is equal to x of n minus y of n. So, from this y of n is equal to E of n minus 1, therefore, from that. So, y of n is equal to the, from this the previous one, x of n minus 1 minus y of n minus 1, you say that, because already given E of n is equal like that. So, from this you say x of n minus 1, y of n minus 1, E of n minus 1. So, instead of this, just to observe that from this relation E of n minus 1 will get y of n minus 1, E of n minus 1 is equal to x of n minus 1 and y of n minus 1. So, therefore, this should be substituted here, that is the y of n, where you say that the n is equal to 0, therefore, y of 0 equal to x of minus 1 minus y of minus 1. So, how we will get which is equal to the 0. So, therefore, here just will say x of n equal to del of n. So, y of 0 equal to the 0, 0 minus 0 which is equal to 0, y of 1 is equal to x of 0 minus y of 0, again x of 0 means 1, y of 0 means 0, 1 minus 0 1. So, again y of 2 equal to x of 1 minus y of 1, x of 1 is 0 and y of 1 is 1. So, therefore, 0 minus 1 minus 1. So, similarly like that. So, therefore, the y of n is equal to 0, 1, minus 1, plus 1, minus 1 up to so on like this, or you say that this is using a Z transformation also. So far not coming Z transformation for you, later we will discuss about the Z transformation. Okay. So, no need to try now, because you are in the unit 1, 2 like that in the semester course. Later you will come to the Z transformation, at that time we will do a lot of exercises by using of the Z transformation. So, here the present output depends only on the present input and past input. Then it is a finite impulse response, that is called the FIR, finite impulse response. How we call it is a finite impulse response? The past and present inputs, output depends on the past and present inputs, then this is called the finite impulse responses. If it also depends on the past output, it is IIR, there is an infinite impulse response filter, the feedback is there, the recursive, you say that. So, this is about the difference between the FIR and IIR. Finite impulse response means you say that only the present and past inputs. If you will consider past output also with that, and it also depends on the past output, then this is called the infinite impulse response functions, filters, you say that, right. So, now the stable and unstable systems, it is a magnitude concept, say that the boundedness amplitudes BIBO, bounded input and bounded output, we will consider. This is already explained all these things in the previous session. Just will observe that whether it is less than infinity, then the system will be stable, right. Just to see the sine and cosine functions like this. This is u of t, unit step function, you say that the del of t impulse function with respect to the time. Sine and cos is stable, just to see this is the y of t is equal to x square of t. If x of t is equal to u of t, then y of t is equal to u square of t, which is nothing but u of t, which is the unit step function. That is a stable continuity, it should be increases, same level it should with respect to the time variation, right. So, magnitude concept, you say that y of t is equal to x of t whole square, the finite whole square, which is nothing but a finite, then the system will be stable, right. So, y of t equal to x of 2t, this is also stable, somewhat finite values will be there with respect to the t. And but here just to observe that this is the y of t equal to t into x of t like this, x of t equal to u of t, you say that, for example, and the y of t equivalent to the t u of t like this. Then t will be increases with you say that this is the ramp function like and so it is an unstable system, it should be varying. And the y of t is equal to d by dt of x of t like that, x of t equal to differentiation of that the unit step function, you say that x of t equal to unit step. So, therefore, d by dt of u of t, which is equal to del of t. This is unbounded. That's why it is called a unstable condition. It should not be satisfied the before. And the y of t is equal to x of t into cos omega ct. So therefore again y of t equal to x of t into cos omega ct. The maximum value for this is either the plus or minus 1 like that. Here the value. So therefore it leads to shows the system is a stable, and the y of t is equal to x of tau into cos omega ct into dt like that, which is also a finite into finite value, but it is minus infinite to the plus infinite. So therefore it shows the output is and the infinitive. So therefore the system will not satisfy the before. So the system is said to be unstable condition. And similarly, just to say the y of n is equal to 2x of n plus 3. This is a finite plus finite which gives the finite. Then the system will be stable. For a discrete, we have del of n and u of n. So therefore, just you observe that y of n is equal to e power x of n, where it is a finite value, then it shows the stable configuration. Stable, system is stable. And so similarly, you say that n terms, then you say that the amplitude which is increasing up to the infinite for this value, then this system is said to be unstable. And if we will take the y of n is equal to sigma of k equivalent to the n minus n naught to n plus n naught x of k, you say that if we take x of k equal to 1, just you observe that here the sigma k equal to n minus n naught to n plus n naught, x of 1, you say that the k minus n plus n naught, which is equal to m. Put you say that, then you may apply the m is equal to 0 to m is equal to 2 n naught. Then the system will give the like this 2 n naught plus 1 y of n is equal to. So this is a finite value is there, which is stable. Invertible and the inverse system. A system is an invertible if the different inputs, the different amplitudes, that leads to different outputs. That is, the two different inputs for a given system should not produce the same output. Okay, if the system is invertible, if the different inputs you are giving to that and the different amplitudes or magnitude, whatever it may be, it leads to different outputs. The two different inputs for a given system should not produce the same output. Okay, somewhat difference will be there. So therefore here just to observe that the two systems is connecting like this x of t, which gives the transfer function of the first system, which gives the y of t, and again it is the invertible you are applying the output of that, then it gives the x of minus 1 like this. So therefore x of t, y of t, again x of t. So therefore this is the transpose t transfer function into transfer function pose, which is equivalent to the 1 like this. This is same output will produce if you are good example Laplace and inverse Laplace, or Z transformation and inverse Z transformation. Both will come into this picture like this. Now you will take the y of t is equal to x square of t, input and output will get u of t and u of t like this, minus u of t and u of t. So therefore non-invertible this is. And again you say y of t equal to x of t minus 4, you say that del of t, you say that del of t minus 4 minus del of t minus del of t minus 4, u of t minus 4 minus u of t minus u of t minus 4 like this. So therefore the invertible inverse is y of t plus 4 like this. So now again you take the y of t is equal to minus infinity to t and the x of tau into d tau. Again you will varying the input and output how it should get. If you will give the input is the del of t, then you will get the output is u of t minus del of t minus u of t like this. v of t and the t x of t, and you say that the minus v of t t u of t. So, here also t u of t here. So, therefore, it is the invertible, the dy by dt, the inverse of this, and you will take another one. You say that the y of t is equal to d by dt of x of t. You say that input is 2, for example. So, the output is for the constant term, you say that 0, any constant term, differentiation of t for the constant term, so differentiation is 0, then it is a non-invertible, and you will take n into x of n like this. This is the property of the del of n only here. Input and output del of n, you say that it gets 0, even it is a minus del of n also, you will get a 0. So, this is a non-invertible. And you will take another example, the y of n is equal to x of n into x of n minus 3. You say that inputs are del of n, so therefore output so the del of n into del of n minus 3, which is equal to 0, and similarly minus del of n is equal to minus del of n into minus del of n minus 3, which is equal to 0. So, therefore, the system is a non-invertible. Similarly, you say that the y of n is equal to sigma of k equal to minus infinite to n and x of k. So, therefore, continuous and discrete. So, therefore, del of n equal to e of n and minus del of n equal minus v of n. So, it is also invertible. This is the n number of examples is there. You may do exercises in the home itself, and now we are going to talk about the linear time invariant systems in the next session. Thank you very much for keep watching.